Hi everybody, welcome back. Today we are going to be working on section 2.8, which is applications of quadratics. Today we'll be studying projectile motion. So if you imagine tossing a ball up in the air or a rocket launching or something like that where it would form a parabola or a parabolic shape, that would be projectile motion. All problems that follow the path of a projectile up into the air and then back down under the force of gravity follow this same formula. H for height equals negative 16t squared, where t is time, plus v times t, where v is the initial velocity, plus c, where c is the starting height of the object. So if you imagine, I don't think that should say Sam. Maybe it should just say Sam, not same. Tosses a penny up into the air with a velocity of 16 feet per second. The penny leaves his hand at a height of 4 feet. So imagine he's standing, right? So the penny's not starting at 0 on the ground. It's starting at some height. In this case, it's 4 feet. Sketch a quick graph of the path of the penny. So we know here, let's say is 0 time, and time passes along that x-axis. So as time passes, let's say here it's going to leave Sam's hand. Here's Sam. Going to leave Sam's hand. He tosses it up and it lands on the ground, right? And we know this is 4 feet because that penny starts at 4 feet and then it ends on the ground. What is the equation of the path formed by the penny? So we know our equation will always say h equals negative 16t squared, plus we know our initial velocity is 16 from up here, so 16t, plus that initial height, the starting height is c, and that was 4 feet. Okay? When does the penny reach a maximum height? Now, when we're doing these application problems, we're actually going to start using Desmos to look at our graph. Okay? Imagine the maximum height would be this highest point. Okay? That highest point would be the maximum, which is the vertex. Okay? When does the penny reach a maximum height? Well, that when question will be the t value, so that will be the time. So you're looking for the x coordinate of our vertex. So now what we're going to do is we're going to punch our equation into Desmos, but we'll use x instead of t just because Desmos likes x better. Plus 16x plus 4. Okay, now if we look at this graph, we can see right there at 4 is where it started, launched up, and there we reach our vertex of 1/2, 8. So when does it reach a maximum height? At 1/2 or 0.5 seconds. Or after half of a second. What is the maximum height? Well, that would be at that maximum with our vertex of 0.58. But this, remember, is your vertical variable, so your height is what we're looking for, which would be the y-coordinate of that vertex. So 8 feet. How long does the penny take to reach the ground? So now if I jump back to my graph, we want to find that point. Oh, shoot, I let the equation go away. So if we think about our equation, here it reaches the ground right there at 1.207. The height is 0, so it's at the ground. So it takes 1.207 seconds to hit the ground. Okay, let's look at another one. Riley shot an arrow upward from the top of a 90-foot cliff with an initial velocity of 64 feet per second. The arrow was 6 feet above the cliff when it was released. Okay, so we know we've got this like cliff, and here's Riley standing at the top of the cliff. They're going to shoot an arrow, or Riley's going to shoot an arrow up, and then it'll land on the ground. Okay, so what we can do is we can draw our x and our y axis. Here's the y axis. Here's the x, the t in time. This would be h for height. Okay, we know that this was 90 feet. Oops. And then we released it another 6 feet. So we know this should be 96 feet. Okay. What is the equation of the path formed by this projectile? So we know it's always h equals negative 16t squared plus the initial velocity times t plus that initial height. Now our initial height is the 96, right? It's from zero. How far from zero from the ground? Well, they're 96 feet when you count the 90-foot cliff and the 6 feet above that. When does the arrow reach its maximum? So we want the vertex point. When means we're looking for a time, which is the x-coordinate. Okay, so if we use our Desmos, oops. Oh my goodness, sorry guys. There we go. I wonder actually if I just screen share then. There we go. This should be a bit better. Okay, so now we've got negative 16x squared plus 64x plus 96. So if we shrink our graph, we can see it goes up so high. Okay, we're looking for this vertex point, which is the point 2, 160. So that tells me after 2 seconds, it reaches its max. What is the maximum? So that's again the vertex, but that is a height that we're searching for. So we want the y-coordinate. Okay, that would be 160 feet. How long does it take for the arrow to hit the ground? Now, for it to hit the ground, that's this point right here where it hits that x-axis. So we're looking right there at 5.1620. So it takes 5.162 seconds to land on the ground. Okay. Now, example 3, you are trying to dunk a basketball. You know that you need to be able to jump 2.5 feet in the air to dunk the basketball. The height that your feet are above the ground when you jump is given by the function h of t equals negative 16t squared plus 12t. So your initial velocity must have been 12. And then notice we have 0 there afterwards because your feet start on the ground at 0. So here, if we graph, here you are. You're going to jump and your feet are going to follow this path. Okay, now they're going to follow that path along the time t. Oops, sorry guys. With a height of 0. So, shoot, it got rid of my drawing here. So you are going to jump in the air. Okay, this is t, here's our height. What is the initial velocity with which you can jump? We just said that initial velocity is always your b value in your equation. So it is 12 feet per second. Okay, why does it make sense that the equation has no c value? And that's because you start on the ground. will you be able to dunk the ball? So remember, we need to know that we can jump 2.5 feet in the air. So what we want to find is, what is this maximum point? How high can we go at our highest point? And if at some point we reach or we go higher than 2.5, we know we're good. So now in Desmos, I'm going to plug in our equation, negative 16t squared, or x squared, plus 12t, or x. Okay. Oopsies. So here we're way, way shorter. If we look, that vertex point is the point 0.375 to 0.25. So that tells me after 0.375 seconds, the bottom of your feet are 2.25 feet up. We will not be able to dunk because you have to be able to jump 2.5 feet in the air. So in this case, no, because your max is only 2.25 feet, okay, and you needed it to be 2.5. Okay, guys, we have 2 exit ticket problems here. Use Desmos to graph them, assess the different parts. Remember vertex, the x-intercepts tell us when it hits the ground. Any x-coordinate counts for time, whereas the y-coordinates count for height. Okay, I'll talk to you soon. Hope you're having a good day.